Unequal heating of Earth's surface is the cause of the general air circulation. With the balance of tropical and polar regions, heat transfers unequally across the surface. When the surface is heated, it develops low pressure, and as it's cooled, the pressure rises. Wind is the result of horizontal differences in air pressure. As stated previously, air flows from high pressure to low pressure because of unequal heating of the Earth's surface, the difference in pressure and location. On the picture we see here, you can see based on the location and the seasons as well, because picture A is in January versus picture B is in July, you can see that the air circulation changes based off of that. Solar radiation is the energy source for most wind. The pressure gradient forces caused by air being subjected to greater pressure on one side versus the other. These pressure differences cause the wind to blow, and the greater these differences, the greater the wind speed. Unequal Here we see a picture that shows some different symbols. With it, we see the wind speed symbols as well as how fast those winds are going. And it also gives us a little key in regards to the isobars that we'll talk about. But what this tells us is which way the wind is blowing and why that direction is happening. So we know that wind is horizontal air movement. The pressure movements are shown on weather maps using isobars. The spacing of the isobars shows the pressure change. The wind direction is shown as wind arrow shafts, and speed is shown as wind bars. With the pressure gradient being the driving force of the wind, it directs the wind across the isobars at right angles, but because of Earth's rotation, that becomes difficult. Winds deflect to the right of their path of motion in the northern hemisphere and to the left in the southern hemisphere. The Coriolis effect is when the direction of the winds deviate due to Earth's rotation. With this, once the air begins to accelerate, the Coriolis effect deflects the air to the right in the northern hemisphere. Greater wind speeds result in a stronger Coriolis effect. The faster the wind speed, the greater the deflection. The Coriolis effect will balance the pressure gradient force, and the wind will blow parallel to the isobars. So here in this picture, you can see that we're comparing the northern hemisphere as if we were looking at Earth head on, and then as if we were looking at Earth in the outer space where the target is. So you see on the upper left picture, it looks as if Earth is not rotating. So that is what the winds would look like if Earth wasn't rotating and the winds were vertical versus horizontal. This is actually a photo pulled from our textbook that talked about a rocket being launched, and so that rocket would look like it was just going north and south, whereas in actuality, with the rotation of the Earth, we see in picture B, the bottom left, the line isn't necessarily straight vertical, there is a slight curve. So this is what happens with the Coriolis effect too, is when the Earth is rotating, those wind directions change based off that rotation. So we know that air that moves horizontally between high and low pressure zones make wind. However, warm air still rises, creating the low pressure zone, and cool air sinks, creating the high pressure zone. So air moving between large and high low pressure systems create the global wind belts that affect the regional climate. So here's the picture of the Dust Bowl that I pulled out of our textbook, talking about the general impacts, or I'm sorry, the impacts of general air circulation on climate in certain areas. The impact here was the winds picked up the dust and blew the dust all over, caused damage as well as health issues with the individuals that were present at that time. Not only does it affect specific areas in the United States, it's all over the world. When those locations don't have the natural barriers to protect them from the specific winds and air circulation, they tend to see more of the climate issues versus those that have the natural barriers surrounding them.